I'm going for the next problem, which is for method of sections. In this question, determine the forces in member CF and GC, member CF and member GC. Of the roof truss shown in figure, state whether the member are in tension or compression. The reactions at the supports have been calculated. So all the reactions are given already. We have to find out the forces of CF and GC. As this is the method of section, first we have to make a section AA of this truss and see this section here. Just cut down the member GF, CF and DC. In this figure, cos 30 equal to 4 by EF, because from the trigonometry you know that cos value equal to base divided by the this bar. So we can get the value of FE from this equation. FE equal to 4 by cos 30, which will be 4.61. We need this value because we are taking moment about point E, and we need this distance to consider the moment for 3 kN load. Now consider the moment at point E. In that case, it will be 3 into EF. EF means 4.61, and another forces FCF. In case of C forces, only the vertical member of these forces will consider for the moment, because for the horizontal member it goes through the point E, so this will not considerable. Only vertical member will be considerable. Vertical member will be FCF sin 30 into 8. 8 will be the distance, 4 meter plus 4 meter. And this is the vertical component of FCF. Now after calculating this equation, you will got FCF equal to 3.45. This is one of the answer of this question, and now we have to determine another members forces, which is FGC. For that member, we have to cut down the truss at BB section. Look at the BB section, which cutted the members GH, GC, FC and DC. So we already we cut 4 members for this section. Consider the section for BB. In this case, we have to determine the value of AH, like the same way as the previous. 4 by cos 30. 4 is this distance. So AH will be 4.61. Now considering moment at point A. In this point we have to consider moment for this 3 kilonewton for this forces FGC, as this member is cut, and the forces for 3.45 which actually FCF, which we calculated from our previous moment equation. We know this value is now 3.45. So look at this moment equation. This is 3 into 4.61. This 3 into this distance AH, AH 4.61, and the FGC, these forces into 8 FGC, and the forces 3.45 FCF into 8, because these forces acting at C point and the distance of C point and A equal to 8. From this equation we get the value of FGC, which is 3.45 kilonewton. So do you have any question for this moment equation? Is it clear to you? Okay, I'm going for the next problem, where this is a bit typical problem, and this is from activity 5.2. Determine the forces in member GF and GD of the truss shown in figure. State whether the member are in tension or compression. The reaction at supports have been calculated. Now let's see how we determine this figure. So from this figure we have to calculate the forces for GC and GD and GF. Now what we did, we extend the member GF up to O, where we cut the member DE. This is extension of the member DE. So we need to know the angle and the distance of EO, this distance x. If we consider this is 4.5 and this is 3, so up to this will be 1.5, and this distance is actually 3, and this is 4.5. If we extend this bar, we assume this value is x. We have to determine this x distance, so just apply the proportional triangles, which is 1.5 divided by 3 equal to 4.5 divided by 6 plus x. So from this small triangle and this big triangle, the distance of this big triangle is 3 into 3, 3 and x, so 6 plus x, and height is 4.5, so x will be 3. So we already got the value of x, and the distance of from the middle point C to O will be 9 meter. Now if you assume the angle of point E equal to alpha 1 and the angle at point O equal to alpha 2, just apply the trigonometry. Tan alpha 1 equal to 4.5 by 3. Just look at this figure. We consider this figure. Alpha 1 equal to 4.5 by 3 and alpha 2 equal to 4.5 by 9. If you do it at inverse, it will be 26.6 degree. And now taking moment at point D, FGF equal to sine 26.6, because we are considering only the vertical part of this force FGF, into 6 FG these forces on the vertical part, FGF into 6, because we consider the moment at G. Moment at D, and the direct force 4 kilonewton into 3, this distance 4 kilonewton into 3, and the after calculating FGF equal to 4.46 kilonewton and taking moment at point O, in that case you have to consider the forces at FGD working at point D. So from this distance 3 plus 3 equal to 6, consider the force for the vertical component FGD sine 56.3 into 6, and for this 4 kilonewton and this 1 kilonewton into 6. After calculating this value, the result will be FGD equal to 1.2 kilonewton, and this is actually the answer of the forces for member GF and GD. And this is the end of the solution of the third problem. So do you have any question? Any other question from our previous problem? Okay, this is end of our today's session. So let me know if you cannot follow me, or if you are facing any trouble with solving these problems. Just email me or phone me. Thank you so much for your attention today. Bye.